Welcome everyone. This is 3.1 on quadratic functions and models. I'm just going to give you the general notes, and then we'll do more practice in class. Okay, so quadratic functions and models 3.1. Here we go. So the first thing is you have to know about the degree of the function of a polynomial. The degree of the polynomial is the greatest exponent. The greatest exponent is the degree of the function. Okay, so whatever you see the greatest exponent is, that's your degree. Okay, pretty simple. If there are multiple variables in the function itself, okay, then it's the sum of the exponents. All right, so here are a few examples. All right, two examples. So what is the degree of this function of f of x equals x cubed minus 2x squared plus x minus 1? Well, this one is simple. The greatest exponent that I see is this 3, right? So the degree of the function is third degree. Okay? That's it. We're just classifying it as a third degree polynomial. Okay? And if we have multiple variables here, we have an x and a y, right? We're just going to get the sum. So this monomial here is 4 plus 2, so that's 6. We are adding the exponents up. This is a 3, and there's an imaginary 1 at the y. So it's 3 plus 1, or 4. This monomial here is 2. Whenever there's a constant, okay, the degree of that constant is 0. Okay, really quick, why it's 0 of any constant if it's a 1? Because I can go x to the 0 power. And remember, anything to the 0 power equals 1. So that is just like saying, hey, look, my exponent is 0. So that's why the degree of this monomial or this constant or any constant is 0. Because you could add an x to the 0 or whatever the variable is to the 0 power. So if you look at it, if you analyze this monomial is 6, this monomial degree is 4, this monomial degree is 2, this monomial degree is 0. So the highest or the greatest exponent or the greatest sum is 6. So this is a 6th degree polynomial. Okay, so we're just classifying it as a 6th degree polynomial. Okay, so what the quadratic function is, it's actually a polynomial function with a degree of 2. So the greatest exponent that you will see is a squared. Okay, so in general form, it's going to be this, ax squared plus bx plus c, where a cannot equal 0, because if it does, then this x squared goes away and it's a linear function. Okay, so just be aware of that. Okay, and now the standard form of a quadratic function, of a quadratic, is this. Okay, look at how a was factored out, x minus h quantity squared plus k. Okay, so that's the standard form of a quadratic function. All right, where your vertex of this quadratic is actually h comma k, and we'll talk more about that in a little bit. And we get this form. So what we're going to do today is we are going to learn how to get that form from this form to this form. And we use completing the square And I do have an example here, so we're going to cover that in a little bit. All right? Okay. So if my A value is positive, okay, A is greater than 0, that means that it's positive. If A value is positive, let me just focus on the positive part, then the parabola actually opens upwards. If you did not know, an an polynomial with a function with a degree of 2 is going to be a parabola. If A is positive, then it's going to open upwards. Okay, and then here's my vertex. That point right there is my vertex. That's going to be the lowest point, and it's going to be H and then K. All right, in this H and K. Okay, that's why H comma K is my vertex, because those are my X and my Y values. Okay, so if it opens upwards, right? Here's a train of thought. If A is positive or is greater than 0, then I know it opens upwards, and that's going to be my vertex. And if A is positive again, then this here is my minimum value. Okay? Is my minimum value is your K value. Okay, the minimum point, the lowest Y value here is that vertex. Okay? So that's my train of thought. And here on the other side, I have the negative version. If A is negative, right? If A is less than 0 or negative, then the parabola opens downward. And you can see if this point is my vertex, then my vertex point K will have a maximum value. Okay, it's maximum, not minimum. Okay? All right. So let's try and do an example of getting it from general form to standard form. So I have this, okay? Remember that my standard form is f of x equals a absolute, or a parentheses x minus h quantity squared plus k, okay? Where h comma k is my vertex. So here are the steps, okay? I'm gonna rewrite this so I can work with it. Okay. Here are the steps to completing the square. I'm gonna go step by step, and I'm gonna have this up here in the video so you guys can just write it down. But I'm gonna go step by step. So first, we're gonna put parentheses around the x. Okay. In blue, I'm gonna put parentheses around the x. So I have parentheses there, and all the x. Okay, 2x squared minus 12x plus 13 on the outside equals f of x. Okay, that's the first step. Just to put parentheses around the variable x, or x squared. The second step is to factor out the a. So if I factor out this a from the blue parentheses, I'm gonna have a 2 out there. If I take out a 2 from 2x squared, I have x squared left over. If I factor out a 2 out of 12x, I would have 6x left over. Okay, plus 13 equals f of x. Okay. In red, or no, I skipped it. Step number 3, with the coefficient of x, I'm going to half it and I'm going to square it. Okay. So the coefficient of x is actually negative 6. So I'm going to get negative 6. I'm going to half it. That means dividing it by 2. And then I'm going to square it. Okay. Simplifying this number, that's negative 3 squared, or 9. All right. So I got 9. That's my third step. In the same color, I'm going to do step 4. I'm going to add the number, that number, to the inside of the parentheses. Okay. I want to get this number. I'm going to add 9 here. So I have f of x equals 2 parentheses x squared minus 6x plus 9 plus 13. All right. And in another color, okay, in this magenta color, I'm going to subtract the total value on the same side. Because I added 9 here, and why the reasoning behind subtracting the total value, because I added 9 here, I changed the whole equation. Okay. Because I changed the whole equation by adding 9 here, I'm going to have to tip it back. So since I added, I'm going to subtract. But what is the total value that I actually added? I added 9 here inside my parentheses. But look where what the number is on the outside of the parentheses. It's a 2, right? And then remember, if I put it back in, I'm going to get 2 times 9. So that's why the total value that I added is actually 2 times 9. 2 times 9, or 18. Okay, I'll go over that again. I added 9 here, and the reason why I added 9 here, you're going to get to it in a little bit. But I added 9 on the inside of my parentheses. I added a total value of 18. 2 times 9. Okay, which is 18. So I have to subtract 18 and not 9. All right? And then my last step here, step 5, I'm going to factor it out. So factor out what's inside here. If you do not know the special form, then you can factor it out however you wish. Okay. But if you factor it out, it's going to be x minus 3 times x minus 3, or x minus 3 quantity squared. And simplify what's here as well. That's plus 13 minus 18. That's going to be a minus 5 equals f of x. Okay. So here, I got my standard form. Okay. That's the standard form of this equation. So this here is the same equation as this. Okay, we just have it in different forms. All right. For part B, it says to find the vertex and any intercepts, x and y intercepts. The vertex is pretty simple to spot. Look at your standard form. This is going to be A. My A value is 2. My H value is 3. And my K value is negative 5. Okay, so my vertex is 3 comma negative 5. H comma K. Okay, to find my x and y intercepts, I'm going to first look at my y-intercept first, okay? To find my y-intercept, I have to make x equal to 0, okay? So because I'm going to make a little graph here, I'm going to kind of cover why I have to make x equal to 0. Graphically speaking, my y-intercept is going to be on this line somewhere, right? Somewhere along this line is my y-intercept, correct? So if somewhere along this line is my y-intercept, that on this line, my x value is always going to equal 0, right? If I count this as 1, 2, 3, 4, 5, 6, 7, this point here is 0, 7. This point here is 0, 3. This point here, 1, 2, 3, is 0, -3. Okay, so wherever along this line, one thing stays constant, and that means that my x, that constant thing is x equals 0. Okay, so I know if I trying to find my y-intercept, I have to make x equal to 0, and I'm going to use the general form for that, okay, because it's just easier to find. You can probably spot it right now what my y-intercept is, okay, but for those who cannot, I will show you. F of 0 is going to equal 2 times 0 squared minus 12 times 0. I'm just adding zeros here and here, plus 13. Okay, if you simplify this out, that's going to be 2 times 0 minus 0 plus 13. 2 times 0 is 0 minus 0 plus 13. That's just 13. F of 0 equals 13. So I have my x or my y-intercept as 0, 13. Okay? You can use whatever form that you want to figure these out. Okay, you can use this form or this form, doesn't really matter. Okay, my x-intercept, I'm going to create y equals 0. Same thing, vice versa. Okay, going back to this, along this line is my x-intercept, right? Whatever this point. Any point along this line is my x-intercept because that's where it crosses the x-axis. Okay? What's constant about that? That means that y is equal to 0. For example, if I take this point here, this point is 2, 0. This point here, 1, 2, 3, 4, negative 4, 0. The constant thing is that my y value is 0. Okay, so that's why algebraically I make y equal to 0, and then I solve. Okay, so you can use either or, this one or this one. It doesn't matter. I'm going to use this one here. Okay, I'll actually show you guys both. So if I use the standard form, 2 times x minus 3 quantity squared minus 5, I am going to solve for x. So I'm going to add 5 to both sides. And that will get me 5 equals 2 times x minus 3 quantity squared. And then I'm going to divide by 2 on both sides. We get 5 over 2 equals x minus 3 quantity squared. Then I'm going to square root both sides. Square rooting both sides. If I square root this side, you're going to come out with a plus or a minus. Okay? Square root of 5 over 2 equals x minus 3. Add 3 to both sides. You're going to end up with 3 plus or minus square root of 5 halves equals x. So here are my x-intercepts. Okay? If you do 3 plus this and 3 minus that, you're going to come out with, on your calculator, you're going to come out with 1.42 or 4.58. Okay? So 3 plus this is 4.58. 3 minus this is 1.42. All right? And I'm going to show you guys the other way. Okay? Now, if I use the other one, the standard form, no, the general form, that I'm going to use my quadratic formula. Okay, so 0 equals 2x squared minus 12x plus 13. Remember that your a value is 2, your b value is negative 12, and your c value is 13, right? And now using these numbers, I'm going to go x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so that's negative 12 plus or minus the square root of negative 12 squared, because my b value is negative 12, minus 4 times my a, which is 2, times my c, which is 13, all over 2 times 2. Okay, so that is positive 12 plus or minus square root of 144 minus 132, I believe. 10 times 26. 104. All over 4. This is 12 plus or minus the square root of 40. All over 4. And then 40, you can break it down. Remember, 4 and 10. So that's 12 plus or minus the 4 can come out as 2 and 2, right? As a 2, square root of 10 over 4. And if you simplify this 4 goes to actually both the 12 and the 2 rad 10. Okay, so yeah, let's just do it that way. 12 divided by 4 plus or minus 2 square root of 10 divided by 4. So that's 3 plus or minus square root of 10 over 2. Okay, that is actually the same thing as this. Okay, I'll show you guys in class why this is the same thing as that. All right, but we get the same numbers, we get the same x-intercepts. All right, so we got our x-intercept, we got our vertex, and now we're going to sketch the graph. Okay, so just to review, my vertex is 3, 5. My y-intercept is 0, comma 13, I believe. 0, comma 13, yes. And my x-intercepts in point-wise, there's 2 points. It's 1.42, comma 0, and 4.58, comma 0. Okay? So here, I'm going to go all the way up to 13. Let me see. 1, 2, 3, 4, 5. Yeah, I can go to 13 by ones. So 3, 1, 2, 3, comma, -5, not 5. 1, 2, 3, 4, 5. -5 is right there. That's my vertex. Okay, V for vertex. My x-intercepts are 1.42 and 4.58. So 1, 2, 3, 4.58 is like here. 13, 0, comma 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right there. Okay, so not right now, all I have, and try your best to kind of make that. Okay. Right now I have that, right? As my parabola. Now now you know that a parabola is kind of even on both sides from the vertex. So that's my mirror. This is actually a special line called the axis of symmetry. We're not going to talk about it right now. This is axis of symmetry. Okay. And since this point here, my y-intercept is 1, 2, 3 units away, I'm going to go 1, 2, 3 units away, and there's another point on my parabola. So here, to finish out the parabola, I'm going to just go up all the way over there. And that's my parabola. Okay? Cool. So now we have to find the domain and the range. My domain, looking back, well, let me write it out here. F of x equals 2x minus 3 quantity squared minus 5, right? Are there any restrictions on my domain? Remember, we talked about the restrictions on the domain. Is the square root, or is anything that's anything that my denominator can't have a 0, right? There's no fraction here. There's no square roots here. There's no even powered roots here. So there are no restrictions. So it's negative infinity to positive infinity. Okay. My range, you can see that my range goes from -5 and up, right? So it's bracket -5, comma, infinity, parentheses. My max value or my minimum value is actually going to be 3, comma, -5. The value of this is -5. Where it is x equals 3. Okay, I just added that right now just for your information. Okay? All right. We can find the vertex algebraically as well. It doesn't have to be all graphing and find the vertex through the vertex form. We can find the vertex algebraically too. Okay, so that is my general form, right? So the x value of the vertex, the h, which is the x value of the vertex, is going to be -b over 2a. All right? So if I use that, and again, I have some notes on the max and the minimum, okay? And it's always going to be based off of that vertex, right? So if you, for example, if you are asked to find the max or min of this, since my A value here is -2, my B value here is 4, my C value here is -5. If my A is positive, right, that means that it's positive, then the parabola is upward facing. Therefore, my vertex here is actually the minimum, okay? And the max, and the minimum value is the Y value, all right? If my A is negative, then the parabola is facing downwards, and my vertex is here. Right? My vertex is there. Therefore, there's a maximum there at the vertex, and that is going to be the Y value. Or if I plug in my X here, right, negative B over 2A into my function. All right? So here's the train of thought. I have to find the minimum or maximum. I have my A, my B, my C value. My A value is negative, right? So if it's negative, then I know it's going to be like this, correct? So that point right there is my maximum. I know I have a maximum. I'm not going to find my minimum. I'm going to find my maximum. Okay. So if I plug it in to this equation, negative B over 2A, that's -4 over, because my B value is 4, 2 times -2, which is my A value. That's -4 over -4, which is 1, right? So the vertex point is going to be 1 comma something. That's what that means, okay? In order to find that something, I'm going to plug in, or it's not f, huh? It's g. G of 1 into the function here. So -2 times 1 squared plus 4 times 1 minus 5. And just doing some simple calculations, -2 times 1 plus 4 minus 5. That's -2 plus 4 minus 5. That is going to be 7. That's -3, right? So my vertex is 1 comma -3. So I have a maximum value. I have a max value of 3 at x equals 1, or you can put your vertex point. Okay? Either one would work. All right, and that is the lesson for 3.1. I'll see you guys on the next one. Bye.